DNP3 Basics, Lesson 7, Application Layer, Object Group Headers and Qualifiers. Now we get to the main purpose of DNP3, to transfer data between the master and outstation. Everything up till now was overhead. The data link layer was a way to say, okay, we are going to send something meaningful. The transport layer was a way to say, we might send a lot of meaningful stuff. The application header was a way to say, okay, we really mean it. Now we hope to get to the stuff. And the place where we are in the entire DNP3 picture is at the object group and variation, qualifier, and range area. The object group, variation, qualifier, and range are contained in an object header, which has 3 parts at least, but more commonly 4. These include the object type field with object group and variation, the qualifier field, and the range field. The object type field contains the object group, 1 octet, which defines what is being sent, such as analog static data. The variation, which is 1 octet, and defines the item format, such as 16-bit integer. The qualifier is 1 octet and defines how the items are organized, such as a range of sequential point indices. The range can be 0 to 4 octets and clarifies the qualifier, such as indices 0 to 7. So let's go over these fields one at a time: object group, variation, qualifier, and range. We are now going to talk about object groups, but before we continue, please remember what was mentioned in Lesson 2. We are constraining discussions to the DNP3 subset levels. This means that there are many more DNP3 object groups than are going to be discussed. And for many of these object groups, there may be more variations than discussed. This class is considering only those object groups and variations that are part of DNP3 subset levels 1, 2, or 3. Having said that, DNP3 subset levels 1, 2, and 3 allow the following object groups. Objects at the left are input points. Those at the right are for other purposes. Note that most input points have 2 object groups, one for static data, current values, and one for events. This is true for binary, analog, and for both current and frozen counters. Binary and analog output status points, which return endpoint values associated with output controls, have only a static input object group. Actually, DNP3 does define event groups for these point types, but the event groups are not part of the subsets and therefore not part of this class. All objects will be discussed later. The second octet of the object header is the variation, which defines how information in the point object is formatted. Variations for input points define how the point's value is formatted, whether point flags are reported, and for binary events, whether a timestamp is included. The table presents subset admissible variations for each subset admissible object. Again, there are more variations than shown. Those not part of the subsets are omitted from the table. Even so, there are a lot of them. For now, it is best to just get a feeling for what variations mean and make notes to reference this table when needed. We will discuss the variations in more detail in future lessons. One significant point to mention now is the flags column. Among other differences, one thing each variation indicates is whether or not the point is reported with flags. For each input object, an outstation maintains a set of 1-bit information fields called flags. These describe characteristics about the point. For example, whether it is online or not. Flags may be included in a response message along with the value. They are always included with event objects. They may be included with static objects. The variation used to report the data defines, among other things, whether or not flags are included. There are a set of flag states that are considered normal, when the online flag is set and all other flags reset. If any flag is in any other state, the point is considered abnormal. When a point is reported without flags, it is assumed that all flags are normal. It is a protocol violation otherwise. If a point has at least one flag in an abnormal state, it is not allowed to send a message with a variation that does not report flags, even if the master has explicitly asked the outstation to do so. What is important in variations? The important thing to note about the variation is that it tells you if the input point is reported with flags or not. For numeric points, if it is reported as a 16 or 32-bit integer. There are also floating point variations, but they are not part of the subset. And whether or not a timestamp is included and the quality of the timestamp. Also, variations shown in the prior table can be used in requests or responses. In responses, they reflect the data reported. In requests, they suggest a format preferred in a response. The outstation may respond differently if the requested variation misreports the data. An outstation is required to substitute a variation if the master issues a request for a variation without flags when a point to be returned has an abnormal flag set, or if the master issues a request for a variation with time and the event was not recorded with time. The outstation must use a variation without time, and this is a new requirement to be included in the updated IEEE 1815 release. The outstation may substitute a variation if the master issues a request for a variation for a numeric value explicitly with a 16-bit or 32-bit value, and the outstation collected the data with a different size. The outstation can respond with a variation showing the correct size, but it can also adjust the size of the point to conform to how the master wants it. And if the master does not care what variation is reported, it can issue a read using variation 0. The outstation can then respond any way it wants. Variation 0 can only be used in read requests. It cannot be used in responses or in non-read messages. Qualifier field follows the object and variation. It helps quantify which points are being addressed. The range field follows a qualifier and is different based on the qualifier code. For example, if the qualifier says, I am going to ask for some number of events, then the range field defines what that number is. The range field may be omitted if not needed. There are 7 qualifier and range fields allowed by the subsets as shown in the table. Again, since we are considering only subset conformed devices, be aware that there are more choices than presented. And as I said before, be aware it is okay not to care. Qualifier codes shown include codes 0 and 1, which specify a start-stop index in the range field, and it says it's reporting or requesting all points between the start and stop range. The difference between qualifier 0 and 1 is whether the range fields are 1 octet 8 bits each or 2 octets 16 bits each. Qualifier code 6 is used in requests only. It has no range field, and it's a request by the master for the outstation to respond with all points of the type requested. Qualifiers 7 and 8 are used to specify a count of points, and the range field includes that count. Again, qualifier code 7 uses a range field of 1 octet 8 bits, and qualifier code 8 uses a range field of 2 octets. Likewise, qualifiers hex 17 and hex 28 also specify a count of points, but they have an additional got you that each point will be prefaced by the point index. This is a convenient way to return a bunch of points that aren't consecutive, such as points 1, 9, 22. Each point, there'd be 3 points returned, and each point would have the point index in front of the point data. So here are some examples of object group headers. Those of you that are colorblind might have a little bit of a problem with this screen. But the entries at the top are example for messages sent from the master. If we go to the second one, we'll see that it has a function code of 1, which is read, an object group number of 2, which are binary events, an object variation of 2, requesting the events with time, a qualifier of 8, which is a count, and a range of 20 decimal saying the maximum number of events I want is 20. Down in the bottom portion, which is examples in messages sent from the outstation, we see the second entry has a function code of 81 hex, which is response. It's used in almost all responses from an outstation. An object group of 2, which is binary events, which is what was requested. A variation of 2, which specifies events with time. A qualifier of 17, which says I'm going to return events with the point index in front of each event, and a range field of 1 saying I have 1 event to report. Here we have an example of a message interchange shown from the test tool we talked about earlier. We see that the read request specifies object 1, which is binary input points, variation 0, which is any variation, and qualifier 6, which is all points. The response describes object 1, variation 2, which is the variation it used to respond with the data, and a qualifier 0 with a start-stop range specifying points 0 through 7. An outstation response can also contain multiple object headers. If, after you process one header and all the associated data, there are still octets left in the application message, excluding CRC octets, then there will be another object header. There is no limit to the number of these except as constrained by the total maximum application size of 2048 octets. Following is an example with two object headers. The first is for binary inputs and specifies points 0 to 7. This is followed by an object header for analog inputs, also specifying input points 0 to 7. Qualifiers hex 17 and hex 28 are used to report events. These qualifiers include a count of events that are being reported and a point index identification in front of each event. Events are queued as they occur. Therefore, you probably will not have an event for every point. And since events are reported in order of occurrence, they are usually not sequenced by point index number. The hex 17 and 28 qualifiers were designed for this purpose. In the example below, you see two analog change events, object 32, reported using qualifier 17 and a count of two events. The first event, shown in pink, has an index of 0, a flag byte of 1, and a value of 100 decimal. The second event has an index of 1, a flag byte of 1, and a value of 45. Well, that was a long lesson. What did we learn? 1. Application data is presented in a series of objects, each with an object header. 2. Object data type is described by the header's object group. 3. There are a lot of object groups. 4. Object data formatting is described by the header's variation. 5. There are a lot of variations. 6. Object data quantification is described by the header's qualifier and range fields. 7. There are a lot of qualifier and range possibilities. And 8. Each application data area can include one or more object headers followed by the associated object data.